So as I said, we are graphing, but this time we are graphing inequalities. And so we're going to be using our calculator to do that. So first of all, would you pick up your calculator and press the button that says window? Does everybody over here have a calculator? Everybody have a calculator. Press the window. What we are going to do is we are going to change the window to the friendly window. Please enter these numbers, the negative 9.4 and the positive 9.4, into the window of the calculator. Actually, as far as the friendly window goes, these other numbers don't make any difference. These numbers are what make it a friendly window. Did I explain previously why that's a friendly window? In the calculator screen, there are 940 pixel points, those little dots that make up the screen. There are 940 dots going horizontally across the screen. Do you see a connection between those numbers and 940? Hopefully you do. See the 9 and the 4? And so that's going to make our whole numbers right on a pixel point. It's just going to make it in a minute when we trace, it's going to make our trace numbers prettier. So please look at example number 1 in your notes. And so I have told you that example number 1, when we graph it in a minute, it's going to be a solid line. Do you know why it's going to be a solid line? Do you remember that from when we graphed before? Or equal to makes a solid line. Does this have an or equal to? Then it's going to be graphed in a minute. We're going to graph it with the dotted line. So as I said, we're going to use our calculator. So go to the y equals screen. And on the y equals screen, type in the 2 divided by 3, 2/3 x. Now, I use this x right here. You can use alpha x. It doesn't make any difference, but I use this x right here. There's more than one way to get x into your calculator. So we're going to graph that. And you can see right here, that's what the graph looks like. And so how do I get it on my graph paper where it's in the right place? I don't want to just sort of put it on the graph paper. I want to put it on the graph paper correctly. So if you will push the button trace, you can also get these numbers out of the table. If you push trace or table, you can get some exact points that are on. Now, would I want to use that point right there? I'm looking for some pretty points that are going to be on my line. So would that be a pretty point to use? So I could put 3, -2, and 0, -4 on my graph paper. How many points do you need to make a line? 2 points. And so you can put those 2 points on 3 and draw a line through them. When I draw a line, am I drawing a solid line or a dotted line? Solid, because it said or equal to. Okay, you got that on your graph paper. Do you have a note paper? This is example number 1 in your notes. Now, on problem number 1, is that the first equation, problem number 1, is that a greater than or a less than sign? Greater than sign. And so, on my calculator, I am going to left arrow all the way over till that's blinking. left arrow all the way over till that little line there is blinking. Everybody there? And then if I enter once, it changes that into a fat line. If I graphed it, the line going across the graph would be very dark. And if I enter it again, do you see it has a triangle on the top, right-hand side? That's the greater than triangle. So when I graph it, not only do I get the line, I also get the shading. See that? Left arrow. Okay. And so you need to arrow until you get the triangle that looks like that. So over here on my graph, this is the part that the calculator shaded in. Now, the calculator cannot graph this one. What's wrong with the calculator? Why can't it graph that one? It doesn't have a Y. The calculator, if you look at your Y equals screen, the graphing is always Y equals. And this doesn't even have a Y, so we're going to have to graph that one by ourselves. And so it is, was it a dotted line or a solid line? I need a dotted line, and the dotted line is going to go through +2, and it said greater than. On the x-axis, this end over here is greater than, and so this is the part that I'm going to shade in. And the solution is what got shaded in twice. That's the solution. So which part got shaded in twice? This part right here is the solution set. Now, you probably can't do this as easy as I can. On the final exam that we're going to take next week, there are several of these kind of problems, and they don't show anything but the double shading. So that is the solution set, the part that was shaded twice. Okay, so then you had this other part. So is 3 -2 in the shaded part? What's right on the line? And the line is solid. And so that's a yes. If it was on the dotted line, I think we have that one. No. Okay, and so 1, 2, 1, 2, 3, 4. This one's on the dotted line. Since it's dotted, that's what it means. The dotted means that's not included in your answer. 1, 2, 3, 4, 5, and 1. Is this the one we had trouble with last class period? 1, 2, 3, 4, 5, 6, 7, 8, and 1. 8 and 1, is that yes? Now you have a bigger piece of graph paper than I do. What about 8 and 1? Does that look like it's in there for you? Yes or no? Okay. So you think the calculator would be helpful? So example number 2. Do you know why I say this is going to be a solid line and this is going to be a dotted line? This has the or equal to, so it's going to be a solid line. It's better to figure that out before you start graphing so you don't have to erase your lines. By the way, I would not suggest using a pen. So we are going to use our calculator. Y equals negative 3x plus 2. And I'm going to graph it and trace and get some points on that line. The first line has a point at 0, 2. And trace it some more. Two and negative 4. I just find two nice pretty points so that you can make a line. The first line is going to be solid, and so I'm going to put 0 and 2 and 2 and 2 and negative 4 and make a, oops, is that the kind of line I'm supposed to be making? I need a solid line. The other line is x minus 3. Graph it. Now, are you there? Can I have you look up at the screen for a minute? If I trace it, do you see that the spider is on that line? The real name is cursor, but I usually call him a spider. You see how it's on that line? I need to know this line. So if I push the down arrow button up here, it's telling me I'm on the line x minus 3. This right here tells me which line the cursor is on. So this is going to be 0, negative 3. And 3, 0. There's two pretty points for me to graph with a dotted line. I would maybe suggest graphing the lines first and then figuring out the shading. This goes through the point 0, negative 3 and 3, 0. Those are the y-intercept and the x-intercept. Sometimes those are easy points to graph. Can you get that line on your paper? Can I have you look up here? Everybody looking up here. The first line is a less than. If it points to the left, it's a less than. And so I'm going to enter. I arrowed all the way over to the left. Enter, enter. That means greater than. Enter one more time. If the triangle is at the bottom, that means less than. That's going to graph less than the first line. Enter, enter. That's going to be greater than the second line. A triangle at the bottom is less than. A triangle at the top is greater than. So when I graph it, it's going to shade it for me, and the solution is the part that got shaded in twice. The only thing I'm going to put on my graph paper is the part that got shaded in twice. That's this part over here on the left. This is the part that is the solution. Yes. All right, let's do this next part very quickly. Your little chart down there is 4 and negative 4 in the colored in solution point. Is 0, 1, 2, 3 in the colored in part? Is 6 and 5 in the colored in part? Is negative 2, 3 in the colored in part? Would you please go to your homework paper and do problem number 1 at this time? And please ask for help, especially if you need calculator help. They always stack these systems. I need you to write them separately because we've got to get them ready to go in the calculator. To go in the calculator, you have to solve it for y, because on your calculator screen it says y equals. So what am I going to do with this with this 2x? Cancel, cancel. Now, the calculator does not care whether or not you put the 9 first or the 9 last. It does have to have the negative with the 2x. Now, I'm solving for y. What am I going to do with the 3? And some of you divide it like that, right? Do you know what that means? What's getting divided by the 3? The 9 or the 2 or the both of them? To make that completely clear, I've always made my students, when they're doing this division, divide by 3, divide by 3. You're dividing everything by 3. That makes it real clear that you're dividing everything by 3. Now, if you want to, you can make that look prettier, but you don't have to. The calculator does not care whether you reduce that 9 over 3 or not. It doesn't matter to the calculator. So I'm just going to put it in ugly. I'm going to put 9 divided by 3. I'm going to do it up there. 9 divided by, it also doesn't matter which one, minus 2x divided by 3. The calculator doesn't care whether it's pretty or not. And so then when you trace it, 0, 3 is 1 point on the line. And trace it down here some more. Now, would I use that as a pretty point right there? No, I'm going to trace. It doesn't till I find a pretty point. I'm having trouble finding a pretty point. There we go. 6 and negative 1 is a pretty point. All I need is 2 points. I don't have to have half a dozen points. And so my first solid line is 0 and 3 and 6 and negative 1. And it's going to be a solid line. The calculator doesn't care whether it's beautiful when you put that into your calculator. The second equation in this example, I am solving for y, so I'm going to subtract 2x from both sides. Cancel. This does not say y. There's a negative sign out in front. So what do I do about this negative sign out in front? Now, there's one special rule that goes with inequalities. Do you remember that from when we did it before? When you multiply or divide by a negative, what do you have to do with this less than sign? When you multiply or divide by a negative number, you have to change the less than sign to a greater than sign. And so where's my calculator? Once again, my calculator does not care whether I enter this in beautiful form or not. In order to avoid a sign mistake, you can just put it in there ugly. And then I'm going to trace it. Now, this is the other line I need to arrow down until I'm on this line. And so 0, -5 is one of my points. And, okay, and so this is going to be a solid line. And I am going to graph this. Okay, there's my 2 lines. Once you get your 2 lines, then you need to shade it. So in example, in the first line, it is a greater than. So you arrow over to the left. Went too far, so I just keep arrowing, and it'll come back eventually to the greater than. The next one, what was it after I fixed it? Was it greater than also, wasn't it? Were they both greater than? Let me look over here. Can't hit the right screen. This was a greater than, this was a greater than. They're both going to be a greater than, and so when I graph it, what got shaded in twice? I would encourage you just to shade in the double shading, because that's how it's going to be on your final exam. Would you please skip over to problem number 6, example number 6? Did you know I hate word problems as much as you do? I really don't like them. I especially don't like inequality ones. So let's try to figure this out. Anna is trying to balance the time she spends on homework and working. Some of you need to try to do that balance. Some of you are working more than you're doing your homework. Her homework takes at least 15 hours a week. She is expected to work no more than 20 hours a week. She has only 28 hours to dedicate to these 2 activities. What 2 activities? Okay, those are the 2 things that we're going to use variables for. Do you want X and Y, or do you want something else? Okay, so we'll let X represent the hours for the homework, because it was mentioned first. Y equals the hours for working. Now, I said this before. One of the issues some of you had on the last test was trying to put everything in one equation. This is not going to be one equation. Here's the first equation. Her homework takes at least 15 hours. Homework takes at least 15 hours. Which letter were we using for homework? And 15. Now, this is the one that's confusing to me. At least, does that mean less than? Is she going to spend less than 15 hours a week? What does this sentence say? She's going to spend at least. Does that mean she might spend 20 hours a week? Does that mean she can spend 10 hours a week? No. So, especially this phrasing confuses me. At least is going to be a greater than sign. She's got to spend 15 or more. Okay? No more than 20 hours a week at work. The variable for work was Y. So no more than 20. Does that mean she can work 30 hours? Or 10 hours? So it might be less than that 20. But it's not supposed to go over that 20. She has 28 hours a week to dedicate to these two activities. What two activities? The homework and the work are greater than 28 or less than 28? No, she has only that amount. She can't spend 30 hours doing that. That has to be less than or equal to the 28. So, don't try to fit everything in one mathematical sentence. Each phrase got its own mathematical sentence. Okay, would you please flip back over to your homework paper and let's try problem number 2. Problem number 2 is not in the right form. So we have to solve for y. If we're going to solve for y, what are we going to do with the x? And this is a greater than sign, just to remind you. And this line underneath it means that when we graph it in a minute, it's going to have a solid line. I need to solve for y. What am I going to do with the 6x? For y, oops, it wasn't an equal. 6x plus 12. I'm going to divide by the 4. The calculator doesn't care whether you actually divide by 4 or you put that in the calculator like that. You can put it in the calculator ugly or you can make it look prettier. It's up to you. This points to the left, so that's going to be a less than sign. And when I graph it, it's going to be a dotted line on the graph. See if you can get it on the graph correctly, please. Did you check your answer to problem number 2? This paper will be due on Friday. And which ones did I tell you to omit?